In this video, I'd like to talk about solving systems of equations with the substitution method. Since remember that there are three distinct methods for solving these systems where you have two or more equations and two or more variables. And in a previous video, we talked about graphing so that we can find the solution, but graphing doesn't really work if the solution is not whole number values for x and y. It's fairly difficult to determine what the solution is by just looking at a graph and seeing where those two lines actually cross each other. Since if this is a fraction or a decimal, it's pretty much impossible to determine visually. So that's one method, and there are two more. In this video, we're going to talk about the substitution method, and in the next video, we'll talk about the elimination method. However, in my opinion, substitution is probably the most useful one to know. Now, graphing definitely has its place because it gives you this visual idea of what's going on, but it's not always effective. However, elimination is always effective, but is sometimes fairly tedious. Now, if the problem's set up where both equations are written in standard form with x and y on the same side, then elimination is probably the fastest. However, in most situations, I would argue that substitution is the one that's best to be used in practice. So what do we mean by the substitution method? So let's look at that picture again of essentially what's happening here. We have two distinct lines that are crossing each other at some point on the coordinate plane. So let's say they're crossing over here. Now what I drew is not what's going on in this system, but it will at least give us an idea of what to do. So at this point here, it intersects at some coordinate x comma y. So at this point, for both lines, this xy solution would solve both equations. Or another way to think about it is at this point, the x value on both lines is the same, and the y value on both lines is the same. So the general strategy we'll have here is that when we have these two equations, we can solve one for one of the letters, either x or y. And then once we have it solved for that, so in this case we solve for x, then I go to the upper equation, and anywhere I see an x, I'm going to replace it with what x is equal to. In this case, x is equal to 3y plus 1. So I plug this in here, and then I'll have an equation that only has y in it. And since it's one equation and one variable, you can actually solve that. You can get a value for y, and then whatever you find for y, you can just plug it back in right here to figure out what x is. So that's the general method. You will solve one of the equations for either x or y. Once you solve it for that variable, you want to plug it into the other equation. Now, a common mistake that students make is they plug it back into the same equation. You can't do that because you'll just get back something that's always true. Something like 1 equals 1, and that information won't really help you. So let's actually jump into this problem and try and solve it. So I'm just going to rewrite it. 3x plus 4y equals minus 23. And this bottom equation has already been solved for x. Now in more difficult substitution problems for these systems of equations, both equations will not be solved for anything. And you'll have to pick one of them to solve for and then plug it into the other one. But in a lot of these exercises, possibly all of them on the Khan Academy, one variable is already solved for. So you don't have to do that first step of actually solving for x. It's already been solved for. Now, once we have one of the variables solved for, in this case x, we're going to go to the other equation and replace x with this entire right-hand side here. So when we do that, we get 3 times in parentheses, and I would recommend putting this in parentheses so that you remember to distribute. So you have 3 times 3y plus 1 plus 4y equals minus 23. And from here, you just solve for y. So we distribute the 3. You get 9y plus 3 plus 4y is minus 23. We can keep working over here, though I'm going to make a little bit more room. And let me switch colors. So this, we can combine like terms. So you get 13y plus 3 is minus 23. And let's subtract 3 on each side. So 13y equals minus 26. And then divide everything by 13 to figure out what y is. And 26 divided by 13 would be 2, but we have that negative. So y is simply negative 2. And now we can use that value, go back up to the second equation, the one we solved for, and just plug in y equals minus 2 there and see what x is. So for that, x would be 3 times y, but y is negative 2, plus 1. And so this is minus 6 plus 1 gives you minus 5. So we think we found x and y. We have the coordinates minus 5, minus 2. Now you might wonder, how do you check this? How do you make sure that this is the solution? Well, the simplest, most straightforward way, though it is a little tedious, is to just plug in your coordinate pair into both equations. So we think it goes through at minus 5, minus 2, and we'll just plug that in here. Now we know in this one, when we plug in minus 5 for x and minus 2 for y, that it does simplify to something true, since that's how we actually found x. So we need to check this top one. So 3 times negative 5 would be negative 15, plus 4 times negative 2, which is negative 8. Negative 15 plus negative 8 is negative 23. So we plugged in our point. It works in both equations, which means we really did find this intersection point. If it only worked in one, then it was probably some point off the line, off one of the lines, but on the other. And if it didn't work in either, then it's some point off in the plane that's not on either line.